In this video, we are going to study degree of subsethood. For fuzzy sets A and B, degree of subsethood tells us to what degree one of the two sets is contained in the other. When we want to know degree of containment of A in B, we write it as subsethood A in B, which is 1 upon scalar cardinality of A into scalar cardinality of A minus summation maximum of 0 and difference A of x minus B of x. This can be found by a formula S of A in B equals scalar cardinality of A intersection B upon scalar cardinality of A. Similarly, when we want to find containment of set B in A, we write it as subsethood S of B in A, which is 1 upon scalar cardinality of B into scalar cardinality of B minus summation maximum of 0 and difference B of x minus A of x. This can also be found by a simple formula S of B in A equals scalar cardinality of A intersection B upon scalar cardinality of B. Let us understand this in detail through simple examples. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. Find degree of subsethood of two fuzzy sets A and B defined on universal set X 0, 1, 2, 3 and 4. The sets are given where A is 0 upon 0 plus 0.5 upon 1 plus etc. plus 0.80 upon 4, and B is given as 1 upon 0 plus 0.9 upon 1 plus etc. plus 0.6 upon 4. From fuzzy set A, we will write scalar cardinality of A, which is 0 plus this 0.5 plus etc. plus this 0.8, which will be 2.71. Similarly, let us write scalar cardinality of B also, which is this 1 plus this 0.9 plus etc. plus this 0.6, which equals 4. Subsethood of set A in B as given above is 1 upon scalar cardinality of A into scalar cardinality of A minus summation of maximum of 0 and difference A of x minus B of x. We will find out this part separately. So we have will be maximum of 0 and difference of this 0 and this 1, 0 minus 1 plus maximum of 0 and difference this 0.5 minus this 0.9 plus etc. plus maximum of 0 and difference this 0.8 and this 0.6. This will be maximum of 0 and minus 1 plus maximum of 0 and minus 0.4 plus etc. plus maximum of 0 and 0.2, which will be this 0 plus this 0 plus this 0 plus this 0.05 plus this 0.20. That will be 0.25. So this is summation of maximum of 0 and difference Ax minus Bx, which is 0.25. Now we will substitute values of scalar cardinality of A, this one, and this value which we have just found out, and this formula 1, and calculate 1 upon 2.71 into 2.71 minus this 0.25, which will be 2.46 upon 2.71, 0.91. So subsethood of A in B is 0.91. We have just found out degree of subsethood of two fuzzy sets A and B according to this formula and got the degree of subsethood of S A in B 0.91. There is a formula for finding subsethood S A in B which is equal to scalar cardinality of A intersection B upon scalar cardinality of A. We will solve this problem by using this formula and see whether we get the same answer as this 0.91 and thus verify that we can directly use this formula to find out degree of subsethood S A in B. We have already seen A intersection B of x is minimum of A of x and B of x, and from which we will write A intersection B to be minimum of this 0 and this one 0 upon 0 plus minimum of this 0.5 and this 0.9 0.5 upon 1 plus etc. plus minimum of this 0.8 and this 0.6 0.6 upon 4, and cardinality of A intersection B equals this 0 plus this 0.5 plus etc. plus this 0.6, which will be 2.46. Now we will use cardinality of A intersection B 2.46 and cardinality of A 2.71 in this formula and find out degree of subsethood S of A in B equals this 2.46 upon this 2.71, which works out to be 0.91, same as this answer 0.91. This verifies that we can directly use this formula to find degree of subsethood A in B. We have to find degree of subsethood S B in A for two given sets. Set A is 0 upon 0 plus 0.5 upon 1 plus etc. plus 0.8 upon 4. Set B 1 upon 0 plus 0.9 upon 1 plus etc. plus 0.6 upon 4. From the formula above, we have to find out scalar cardinality of B, which will be 1 plus 0.9 plus etc. plus 0.6, which is 4. Next, we have to find summation of maximum of 0 and difference B of x minus A of x. Sets A and B are defined on universal set X with elements 0, 1, 2, 3 and 4. This is maximum of 0 and this 1 minus 0, 1 plus maximum of 0 and this 0.9 minus 0.5, 0.4 plus etc. plus maximum of 0 and 0.6 minus 0.8 minus 0.2, which will be 1 plus 0.4 plus 0.14 plus 0 plus 0, which will be 1.54. We name this 1. We will substitute value of scalar cardinality of B 4 and 1.54 in above formula and find S of B in A equals 1 upon 4 into 4 minus 1.54, 2.46 upon 4, 0.665. We name this 2. Now we will find degree of subsethood by the formula that we have seen. S of B in A is scalar cardinality of A intersection B upon scalar cardinality of B. First, we will find out scalar cardinality of A intersection B. For that, we need to find set A intersection B. Let us recall A intersection B of x is minimum of A of x and B of x. From this, we write A intersection B minimum of 0 and 1, 0 upon 0 plus minimum of 0.5 upon 0.9, 0.5 upon 1 plus etc. plus minimum of 0.8 and 0.6, 0.6 upon 4. From this we write scalar cardinality of A intersection B, which is 0.5 plus 0.66 plus 0.6, which is 2.46. Now we will substitute this value and this value in this formula that gives 2.46 upon 4, 0.665, which is exactly the same value here. This also verifies that we can directly use this formula S B in A equals scalar cardinality of A intersection B upon scalar cardinality of B. Two fuzzy sets are obtained by A of x equals x upon x plus 2 and B of x equals 2 raised to minus x, where universal set x is 0, 1, 2, 3, 4 and 5. We have to calculate fuzzy cardinality of set A, fuzzy cardinality of B, subsethood of fuzzy cardinality of A in fuzzy cardinality of set B, and subsethood of fuzzy cardinality of set B in fuzzy cardinality of set A. We have fuzzy set A equals, from this membership grade, this 0, comma 0 upon 0 plus 2, 0, this 1, comma 1 upon 1 plus 2, 1 upon 3, etc., and 5, comma 5 upon 7. Level set L of A will be excluding this 0, this 1 upon 3, this 1 half, etc., and this 5 upon 7. These are values of alpha that we write in decreasing order. So first 5 upon 7, 2 upon 3, etc., and 1 upon 3. Next column is alpha cut A corresponding to alpha equals 5 upon 7. 5 upon 7 cut A will be this 5 corresponding to alpha equals 2 upon 3. 2 upon 3 cut A will be these two elements 4 and 5, etc., and corresponding to alpha equals 1 upon 3. 1 upon 3 cut A will consist of this 1 and all the elements of this fourth row 2, 3, 4 and 5. Next we write scalar cardinality of alpha cut A, that will be number of elements in alpha cut A. Just one element, this 5, two elements 4 and 5, etc., and 5 elements, this 1, 2, 3, 4 and 5. Now we write fuzzy cardinality of set A, that will be from this column alpha, and scalar cardinality of alpha cut A, this 1, comma this 5 upon 7, this 2, comma this 2 upon 3, etc., and this 5, comma this 1 upon 3. Scalar cardinality of fuzzy cardinality of A is this 5 upon 7 plus this 2 upon 3, etc., plus 1 upon 3. That works out to be 2.81. Now according to this definition, B of x equals 2 raised to minus x, we will find fuzzy set B, this 0, comma 2 raised to minus 0, 1, this 1, comma 2 raised to minus 1, half, etc., 5, comma 1 upon 2 raised to 5, 1 upon 32. And level set B, L of B will be this 1, this half, etc., and this 1 upon 32. Now we will prepare table for alpha, alpha cut B, and scalar cardinality of alpha cut B. First column alpha, in decreasing order it will be this 1, then half, etc., and 1 upon 32. Next column is alpha cut B corresponding to alpha equals 1. We have alpha cut B 0. For alpha equals this half, we have this 1 and this 0. For alpha equals 1 upon 4, 1 upon 4 cut B will be this 2, 1 and 0, etc. And for alpha equals 1 upon 32, 1 upon 32 cut B will be this 5 and these 4 elements 4, 3, 2, 1 and 0. And third column, scalar cardinality of alpha cut B for this single element 1, for these two elements 2, etc. and for these 6 elements 1, 2, 3, 4, 5 and 6 here. From this first column and this third column, we will write fuzzy cardinality of set B. So fuzzy cardinality of B will be this 1, comma this 1, this 2, comma this half, etc. and this 6, comma this 1 upon 32. Now scalar cardinality of fuzzy cardinality B will be this 1 plus this half plus etc. plus this 1 upon 32 will be 1.96. Now we have the answer to this question, fuzzy cardinality of A here, then fuzzy cardinality of B here. Now we will write fuzzy cardinality of A intersection fuzzy cardinality of B, which will be minimum of A of x and B of x, that will be 1 comma minimum of 5 upon 7 and 1 5 upon 7, 2 comma minimum of 2 upon 3 and half etc. and 6 comma minimum of 0 and 1 upon 32. Here sixth term 6 comma 0 is not present, so 0 here, and its scalar cardinality will be this 5 upon 7 plus this half plus etc. plus this 0, that works out 1.65. Here we write our final answer, subsethood of scalar cardinality of A in scalar cardinality of B. S of scalar cardinality of A in scalar cardinality of B will be this scalar cardinality of fuzzy cardinality A intersection fuzzy cardinality of B upon scalar cardinality of fuzzy cardinality of A, that will be this 1.65 upon this quantity which we have already found out, 2.81, gives us 0.58. Next we write answer to this question, subsethood of fuzzy cardinality of B in fuzzy cardinality of A. S of fuzzy cardinality of B in fuzzy cardinality of A, which is scalar cardinality of fuzzy cardinality of A intersection fuzzy cardinality of B upon scalar cardinality of fuzzy cardinality of B. Using the values this 1.65 upon this 1.96, we get 0.84. So last two answers are 0.58 and 0.84. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.